Okay, Rolle's theorem. Alright, Rolle's theorem is just a specific case of the mean value theorem. Okay. Alright, it says that if the slope of a function or function secant line is 0, in other words, the secant line is horizontal, because the endpoints of the interval are located at the exact same height on the graph then somewhere on that interval the tangent slope will also be 0. So since you already understand the mean value theorem, this isn't new information. Okay? So just remember our previous theorem guaranteed the lines will have the same slope no matter what the secant slope was. Alright, so according to your theorem in your book, it says if a function f of x is continuous and differentiable on a closed interval AB and f of A equals f of B, so those y values for those x values A and B should be the same, then there exists a C between A and B such that the derivative at C is equal to 0. Okay? Okay, and the graphical representation of Rolle's theorem would be this. So we have an x and y axis. Okay, we have a curve here. Alright. Alright, so this point is A. This point is B. Alright. If I drew a secant line through A and B, then the slope of that secant line would be 0. Alright, so the slope of the secant line would be 0. Alright. Alright, so then according to Rolle's theorem, somewhere on that interval, the tangent slope will also be 0. So right here, if we draw the tangent line at the top of this curve here, and if we label this to be C between A and B, then the slope, or the derivative at C, which is the slope of the tangent line, will be equal to 0. Okay? So the function is continuous and differentiable on a closed interval. You see that f of A is equal to f of B. Then according to the theorem, there exists a C between A and B such that f prime of C, or the derivative at C, which is the slope of the tangent line at C, is equal to 0. And that's pretty much Rolle's theorem.